In this lesson today, Unit 5, Lesson 4, we are going to continue with factoring. So remember, factoring is kind of like dividing a polynomial into smaller parts, okay? So factoring, lesson number 2. We're going to skip over this warm-up, and we are going to come down and talk about, just jump right into the notes, difference of squares. So what is a difference of squares? A difference of squares is a binomial. It has to have two terms only. So binomial, it has to be subtraction, and it has to have front number has to be a perfect square, and the back number has to be a perfect square. So these are the criteria for how do you know when to use a difference of squares method, okay? So here is how it will end up looking. I'm looking at this example here. I have a squared in the front. I have a b squared in the back. I definitely see that this is subtraction, so it meets all the criteria, and it's only got those two terms, okay? So what I'm going to do is I'm going to break this down into two smaller terms where I will separate the a's out. Each term gets an a. Each term will get a b. And then my signs, one will be negative, one will be positive. Okay? And that is how I will do difference of squares. So let's look at number 1. First thing I do is I check that I have perfect squares, right? A squared is the same as a times a. Is there a number squared that could give me 4? And there is. It's 2 times 2 is 4. So, and I have this minus sign here. So let's go ahead and write my answer. I have two binomials. I will give each one an a. Since the a square is in the front here, it'll stay in the front when I break them up. And then the 2 is in the back here, so the backs get a 2 and a 2. And then I got to have 1 minus 1 plus. And that's it. So the only other little notes that I really need to add out to the side here is some people don't know all of their perfect squares very well. So I'm going to give you 1 through 15, and then also 20 is good to know. Okay, so 1 squared is 1, 2 squared is 4, 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 49, 64, 81, 100. My signs got a little off. Let's go below that sign. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is going to give me 196. 15 squared is 225. And then 20 squared is 400. All right, so it is really, really good to have all of those memorized. At the very least right now, just have a little list off to the side to help you as you're going through these, okay? So just like I did in example number 1, I checked that the front term was a perfect square. The back term, I broke it down so I could see what the square term is, and then the minus sign. I just checked all 3 criteria. So let's take a look at number 6. I have a 1 in the front. And a lot of students think, well, that's not a perfect square. You can't break that down. But actually you can. It's right here. 1 is the same as 1 times 1, right? And now let's look at the backs. 49 is 7 times 7. Don't forget to break down the y times y. And it does have a minus sign, so I'm ready to fill in my answer. Okay, so 1's in the front, 7 and a y, 7 and a y, and then minus, plus. Now, if you write your signs the other way around, let's say your answer looked like 1 plus 7y and 1 minus 7y, that is totally okay to switch those around. The order doesn't matter, okay? It's no different than if I had 6 times negative 2 or negative 6 times positive 2. The answer would still be negative 12, right? They equal the same value because I'm multiplying them together. All right. Let's take a look at an example like number 9. Let's do number 9. So in my front, I've got 4 and 4, and I've got A and A. In the back, I have 121, which is 11 times 11. And I definitely see that I have that minus sign there, so this works out perfect. So 4A in the front, 4A in the front, 11 in the back, 11 in the back, and be sure that you've got 1 plus and 1 minus. Okay. All right, let's skip on over to this side of our paper. Again, we're not doing all of our notes anymore. Let's do number 15. I'm going to do 15. So I see that I have in the front, I have 2 and 2, C and C. And then I have that minus sign, which is what I need. And then I've got D and D, but what's the matter with that 5? That is not a perfect square. It cannot be broken down into 2 numbers of equal value that multiply together to equal 5. So if I cannot break this down into smaller parts, hopefully we remember that this is called prime. Okay, so that answer is prime. It's a prime polynomial. Now what I want to do is I want to combine today's lesson with lesson number 3 that you did, which was finding the greatest common factor of polynomials. All right. So for each of these, the very first thing that you ever want to do when you look at a polynomial is GCF, first and always. GCF, that goes first and always. Look for that. Okay. And then after you GCF, we're going to start looking at different methods so that you can apply after GCF. Today, we're learning difference of squares. Our next method will be something else to do with trinomials. Okay, so today we're just dealing with 2 terms. Remember, and a trinomial would be 3 terms. All right, so let's do our GCF first. So I'm going to break this down. The only way to break down a 2 into smaller parts is 2 times 1, and I have n times n. and then I have a 17, and I want to break that down. I want it to have a 2. I want to break it down so that it looks like 2 times something. Okay, because I see that that one has a 2, so I want that one to have something in common. So 2 times what is 72? And the answer is 36. So now I take out my GCF. Remember, take out the GCF to the front, and then in the back, you write your leftovers. So I have n squared minus 36. Yesterday, when I got to this part, I was all done, but today I'm not. Today, I see that I have an n and an n, 6 times 6, and I've got that minus in the middle, so I'm going to break it down. 2 and times, and then I'm going to have 2 sets of parentheses. Okay, so remember, one's minus, one's plus. I'm going to put the 6's in the back and the n's in the front. And that would be my final answer. So it does start to kind of look a little crazy when you've got to do GCF first and then look at other methods to complete after. But let's do another one together. Let's do number 26. We can do number 26. So I'm going to break this down. I see 100 is easily 10 times 10. And then I have B, B, B. 36. Actually, I could get 6 and 6, but I want to make these numbers smaller. I got to find a number that comes out of them both. So let's try 2. 2 times 50 is 100. 2 times 18 is 36. Let's see. 4 times 25 is 100. Can I do that with 36? 4 times 9 is 36. So I want the largest number. So yes, these both work, but I want the largest one that I can take out. Okay, so I'm going to go with the 4 and 25 and the 4 and the 9. 4, 25, 4, and 9. And then this one has a B, and this one has 3 B's. All right, let's find the GCF. A 4 and a 4, a B and a B. So I have a 4B. Now I'm going to write my leftovers. So I have 25, and I have B squared, and then in the back I have a 9. And that is a minus sign right there. So I just brought it down. Okay, now I have to ask myself, can I continue to factor this? And I can. 25 is a perfect square. B squared is perfect square. 9 is a perfect square. And there's a minus sign, so it's a difference. So I can do, let's bring over the 4B, and I'm going to break this leftovers down into 2 parts. Again, that is what factoring means, to take something and break it down into smaller parts. So I have 5B in the front and 5B in the front if I broke that back down, and 3 and 3 in the backs, and then 1 plus, 1 minus. And that is your final answer. All right. So just like as always, I'm encouraging you to use whatever apps or websites that you've been using all year to check yourself when you're practicing at home. Please do not, some of the websites that you use, they don't show the work the same way that I do. And I don't believe that a lot of you would understand what it is that you're copying. if you just go to these websites and type these in and copy. Remember, what you're doing to practice is not graded when you're completing these notes right now. It is just for better understanding. So if you just copy them down from some website, I'm afraid that you're going to lose the understanding. I'd really like for you just to use the answer portion that you get rather than the steps they use along the way. All right. There is another assignment posted to Google Classroom that goes along with this lesson. Until next time.